Okay, so hello, and this is my third laboratory exercise with my subject data communication and networking. So the activity title is configuring of IP addresses and subnet mask onto the host. So I'm gonna go through the procedure. So number one is open packet Cisco tracer and connect four PC, one hub and one switch. Click once on PC0 just shown in the figure below. So this is my Cisco packet tracer and add 4 PC. So one, two, three, and four. Okay, and one hub, one switch. So one hub, one hub, and one switch. Use the same model. Okay, then choose the configure tab. You can change the name of PC0. It also it is also here where you will enter the gateway IP address, also known as the default gateway. After after the enter of the IP address is 192.168.1.1. It depends on you. Make sure that it is a 32-bit address. So okay, gonna first I'm gonna connect this PC to this hub. Okay, for PC2 and the switch. Okay, still in the STP process, amber color. Next is I'm gonna go to PC0, configure. Okay, this is the default gateway. So I'm gonna use this is the default gateway, and it is a 32-bit, not as for IPv4. And this is the 64-bit for IPv6. Not gonna use this. I'm gonna use this 32-bit for IPv4. Next is what's the next step? Click on fast Ethernet and add the IP address. Add the IP address 1.1. Entering the default kit. So I already did that. Let's go back here. Oops. Where is the IP address? 192.168.1.1. Okay. Oops. Oh, sorry. I was mistaken. Okay. This one here. Okay. Okay. Next. Okay. Next. Step number 4. Repeat the step from other end devices. Set up IP address of the PC of the 4 PC to 192.168.1.1.10 for PC0. So I already finished on that. So next is 192.168.1.20 for PC1. 192.168.1.30 for PC2, and 192.168.140 for PC3. Okay, so for PC0, PC1, configure fast Ethernet. IP address is 192.168.1.20. Okay, so subnet mask automatically configure. Next is PC2, configure interface fast Ethernet static 192.168.1.30. Okay, so next is PC3, configure fast Ethernet. IP address is 192.168.1.40. Can close. Okay. Connect PC0 and PC1 to hub, and PC2 and PC3 to a switch, and connect the hub to switch 0. Connection is okay if the green light appear on every connection. So check. Oops. Can I use this one here? Here. Okay, so still in amber. Checking whether there is a switching loop. Wait for a while before this become color green or on the forwarding stage. For now, it's in the spanning tree protocol process. Okay, wait for a while. Okay, now it's green. It's in forwarding stage now. Next is number 6 is simulate the network by switching the real mode to simulation mode. The tab is partially hidden behind the real-time tab in the bottom right corner. The tab has an icon that has a watch on it. Okay, so this one, real-time simulation mode. Next is okay. Number 7. After switching on simulation mode, click the envelope and drag it either on one of the PC, and click another envelope to drag it again to another PC, and click auto capture or play button. Observe the flow of the message and determine its status if it's successful or failed. Okay, so here's the envelope. This one, it's simple PDU. So I'm gonna send a message from PC0 to, let's say, PC3, and click the play button. Watch it. Sending an ARP message received by the hub. Okay, forwarded here. This packet here have been dropped. Okay, to from switch 0, it's sending an ARP message. Now this PC here is giving the MAC address or sharing the MAC address for this PC so they can do the three-way handshake. So the hub always rebroadcasting the packets that it received. Then so now they're as you can see this message here. This time it only goes straight to the PC3 because this they now have a three-way communication, a three-way handshake. What I mean. So they establish a connection already. Now they are communicating with each other. Okay, so it's a successful message. Next is, okay, question. What is the importance of gateway? So we use the gateway so that we can or we use the default gateway so that we can communicate with uh, other uh, computer that is on another network. Okay, so usually, for example, let's say, mm, so we use the default gateway so we can communicate with another computer. I will take an example. For example, just for example, this, say this PC, and then uh, let's say a switch, and then I'm gonna use a router, generic router. And then let's say I'm gonna use a server. I'm gonna interconnect them. So for example, this one here, here, here. So let's say this server is, uh, say this is a Facebook. Okay. So this is a Facebook server, and then this PC here wants to communicate with Facebook.com. So wait, forgot to write. Let's say, for example, the IP address of this is 192.168.1.10. Okay, and then this router here, the default gateway is 192.168.1.1. This is the default gateway. And then the IP address of the Facebook server is 50.0.0.1. So in order for them to communicate, first thing this PC needs to do is to know what is the MAC address of this PC here so they can establish a connection. They need to do a three-way handshake. So it's like this. I'm gonna show you what is. Wait, hold on. Three-way handshake. Okay. So what is a three-way handshake? So they need to do the three-way handshake so they can establish a connection. But in order to do that, this PC needs to know what is the MAC address of the Facebook.com. So what this PC gonna do is do an ARP message, or say ARP, or address reso, so resolution protocol, but we can only do the ARP message only within the network. Only, I mean, let's say, hold on a minute. Okay, wait. Establishing epic pen. Oops. There's lag. Okay, let's. So this is the three-way handshake. What time? Okay, this is the epic pen now. Give me a minute. Okay, so this is the three-way handshake. So first they need to synchronize. Then this server will gonna send a sync and acknowledge. Then this PC will gonna send an app, and then they can establish the connection. Okay, back here. So as I'm saying, so this PC needs to know what is the MAC address of this Facebook server in order for them to communicate. So say, here we go again. Slow, again, it's okay. But in order to do that, they need to send the ARP message. But the ARP message, as I mentioned before, it's only work within the network. So it will only work within this side, not within this side. So because this one is in different network, so ARP is only within this side. Okay, so what our PC gonna do if he don't know what is the MAC address of the facebook.com is that he will just gonna send the message to the default gateway. So wait, so wait, so it will gonna send this PC will gonna communicate to its default gateway, and then the default gateway will communicate to that Facebook server. But then this server or this router will gonna uh, the one that will gonna communicate. It's like wait, yeah, just like that. So the server will gonna answer. Then this is the one that will communicate within the server. Every request that will send to the router, then the router will gonna send it to the server, just like that. For example, this in my computer, gonna do a CMD. What's this? Okay, for example, this is my ARP table in my computer. As you can see, there is this is the default gateway of my computer, and this is the ARP table that is saved in my computer. Because this uh, every time my computer will uh, gonna send an ARP, it will gonna save all the MAC address of other the computer that he communicated with. So just like this the physical address, this the MAC address. Okay, so what I'm gonna do now is try to communicate with Facebook.com. So I'm gonna ping the facebook.com. So as you can see, the IP address of facebook.com is 157.240.13.1.35. Okay, now I'm gonna check the my ARP list again in my computer. ARP /A. So as you can see, there is no the IP address and the MAC address of the facebook.com does not save in my computer because only uh, the only the default gateway is saved because the ARP message is only within the same network. Okay, so this default gateway is the one that only communicates with the other network. Okay, so that's it. How do you do this? Ah, no, quit. Okay, so that is the use of the default gateway. Delete this one. Okay, next question. What is the transmission medium used to connect hub and switch? So we use the crossover cable to connect the switch and the hub, because the switch and the hub is almost the same. So wait, okay, uh, crossover cable, over cable. So we use crossover cable with the same device, except may exception. There is an exception on the rules. Except same device for and hub, switch to hub, and computer to router. Okay, so we use crossover cable. So because the switch and the hub is almost the same. Sorry, the switch and the hub is almost the same. It's only different the way they handle the data. So when you when the hub is communicating, we use the hub and you send message to one PC. Everyone that is connected to the hub will receive the same data, also except for the switch. The switch is way smarter than the hub, because uh, it only once he received the message, he will look for its uh, destination of that data. So he will gonna check the what is the MAC address of that data. So what is the destination? So or he will check the frame. Okay, so that's it. So we use the crossover cable to connect the hub and the switch together. So next question. What is the indication if the connection of your PC are successful? So first is, of course, we can see that there is a green light between two sides. So from the hub side there is a green light here, and to this PC0 is color green. I use the fast internet 0 to connect to the hub, and this one here, both side are color green. And yeah, there is a communication between them. Send message. Okay, this can send message from this PC here, and this message can send message back to the sender. So that is how you will know where there is a the connection is successful. Okay, next question. What can you conclude from this activity? So with this activity, I learned about uh, the default gateway, uh, and what is the what is the why do we use the default gateway, and configuring this IP address for the PC, and there's a lot. And what else? I think, yeah, I I understand how the network works. So I think that's it. That's all. So thank you. Wait. No. Okay, so I think that's it. Yeah. So thank you. Bye.